Welcome to the component Introduction to Computer Science, Networks. This is Lecture A. The component Introduction to Computer Science provides a basic overview of computer architecture, data organization, representation and structure, structure of programming languages, and networking and data communication. It also includes some basic terminology from the world of computing. The objectives for this unit on networks are to define what a communication network is, explain the purposes and benefits of a communication network, explain the Internet and World Wide Web, their histories and their structures, describe different ways of connecting to the Internet. Explain the basics of network addressing, Internet Protocol or IP addresses and domain names, and how they can be leased or purchased from an Internet service provider. Introduce network classification by the coverage size. Describe different network topologies, outline different standards and protocols that govern wired and wireless communications. Describe the benefits and disadvantages of wireless communication. Describe typical wireless network hardware. Describe network hardware. And finally, to introduce networking logical models and discuss the Open Systems Interconnection, or OSI model. It is appropriate to begin this discussion with the definition of a network. According to Wikipedia, a network is a collection of computers and devices connected by communications channels that facilitates communication among users. It allows users to share resources with other users. In plain English, a network is comprised of computers, printers, and other devices, along with some sort of media being the cabling and/or the ability to communicate wirelessly, which allows all of the devices to communicate with each other. To visualize what a moderate-sized network would look like, examine the figure on the screen, where you will see two regional offices that are connected to the head office. Remote users, employees who work at home or travel as part of their job, also need to connect to the head office. Note that all users are connecting through the Internet, and that the Internet service providers, or ISPs devices shown in the figure, are interconnecting all of the sites. Additionally, the routers at the regional offices are connecting to a router at the head office. What is the motivation behind creating networks? Connecting devices into networks provides a number of significant benefits. For example, numerous users can share hardware such as printers, scanners, and data storage devices. The users can also simultaneously access software installed on servers, reducing the cost of business. And through networks, people can exchange email and instant messages, chat, and share files such as images, documents, and spreadsheets. It is important to point out that networks decrease costs for business, individuals, and governments. For example, what was once printed documentation can now be located digitally on a web server. This means that users no longer need to update documentation physically. Instead, a web page is updated, and users can be automatically notified of the changes. In the past, technical support teams printed documentation and kept copies at their desks so that they could answer questions that came in from customers. If the documentation changed, someone had to reprint and redistribute the documentation to perhaps 200 technical support agents. Web servers have eliminated that effort and cost. Networking has also brought us email as a form of electronic paperwork, eliminating the need for interoffice paper memos and mailing costs, for example. Finally, networks make it easier to keep device software current. Network administrators no longer need to physically visit each device to manage it or upgrade its software. Through networking, administrators at the home office can locate a remote device, connect to that device, and make changes to it without ever leaving the office. In addition, networks serve customers. For example, documentation can be posted and maintained on online web pages. Customers can be notified of changes by email. Either way, customers will always have the latest information when they visit those specific web pages. Customers can chat with or email customer service representatives. Today, it is common to find live chat services with vendors, where customers can have their questions answered in real time, as opposed to using email that may have taken a vendor several days to respond to. Customer service reps also have access to a common network database containing solutions to common customer requests or issues. In the past, support representatives might have needed printed documentation at their desks when providing tech support to customers. Since this method of providing support is not cost-effective, it is rare to find reps using printed material anymore. Solutions to customer issues can be stored in a database to record whether or not a particular solution was successful. If a solution is unsuccessful and does not solve an associated problem, it can easily be replaced in the database with a solution that is successful, which helps companies improve customer satisfaction. Hospitals can store all patient data in one common network database, which improves the quality of care. Medical staff and patients can access electronic medical records stored in a network database as well. In addition, a patient can easily locate the name of the nurse on another screen. Again, all of this is accomplished by a network. But what exactly is the Internet? According to Wikipedia, the Internet is a global system of interconnected computer networks that use the Internet Protocol Suite, Transmission Control Protocol, Internet Protocol, or TCP/IP to serve billions of users worldwide. So, the Internet is a large network made up of many smaller networks. For example, one small city may connect to other small cities, creating a regional network. That regional network might connect to another regional network, creating an ever larger network, and so on. For some, it would seem that the Internet has been around forever. But really, that is not the case. The Internet originated from a project commissioned by the governments of the USA, UK, and France in the 1960s to build robust, fault-tolerant communication via computer networks. In the United States, the first network was named ARPANET, or Advanced Research Projects Agency Network. The original Internet consisted of 4 computers or servers operating at UCLA, the University of California, Santa Barbara, Stanford, and the University of Utah in 1969, the same year that the United States put a man on the moon. The world quickly saw the benefits of an Internet, so the Internet continued to grow, especially from the mid-90s through today. In 1995, for example, an estimated 16 million people were using the Internet. In 2015, as estimated by International Telecommunication Union, more than 3.17 billion people were using the Internet. The terms Internet and World Wide Web are often used interchangeably, but they are not the same thing. According to Wikipedia, the World Wide Web is an information space where documents and other web resources are identified by URLs, interlinked by hypertext links, and can be accessed via the Internet. A URL, which is short for Uniform Resource Locator, is an address typed into a web browser's address line, such as www.whitehouse.gov. British scientist Tim Berners-Lee is credited with creating the web in 1989 by introducing a web browser and web page coding. When Dr. Berners-Lee created the web, he introduced web browsers and web page coding. A web browser is a software program that lets the user interact with the web by facilitating a connection to other web servers over the Internet. Browsers, including Internet Explorer, Google Chrome, and Mozilla Firefox, use Hypertext Transfer Protocol, or HTTP, to communicate with web servers and retrieve web page content. The web server sends hypertext markup language, or HTML, coding back to the browser, which in turn translates the HTML coding for display on a monitor. The previous slide pointed out that the web server sends HTML coding back to the browser, which translates that HTML coding for display on the user's monitor. Therefore, HTML is the language of the web. Web pages are text files written in the HTML programming language. An example of HTML is shown in the figure on the left side of this slide. Notice the HTML tags enclosed in brackets. This code outputs the web page shown on the right side of the slide. To reproduce the web page output shown above, all you would have to do is type the HTML code into a Notepad document, save the document with the file extension of either HTM or HTML, then double-click on the file to open it. This leads to the question, who owns the web? The answer is that no entity owns the Internet. People and organizations own the devices that connect to the Internet and form the World Wide Web. In fact, these people and organizations also own the content on the web. However, when Google encountered Chinese censorship, it was clear that a country can repress what its citizens read. There is an ongoing discussion of this issue at Wikipedia's webpage titled Internet Censorship in China. Internet service providers, or ISPs, connect users to the Internet. Typically, a user has a contract with an ISP that allows connection to the Internet using the ISP's services. For example, a computer user at home who wants to access the Internet needs to purchase a service plan from an ISP in order to connect to the Internet. In fact, Access to the Internet globally revolves around the use of ISPs. As shown here, ISPs are organized as local, regional, and national providers, and in some cases, even international providers. A Tier 1 ISP is a large national or international provider. A Tier 2 or regional ISP connects a local ISP to Tier 1 ISPs. A Tier 3 ISP is a local Internet service provider. One of the most important characteristics of a network's performance is how fast data can be transmitted between its components. The data transmission rate of a network connection, or in more casual terms, the speed of a network, is characterized in terms of bandwidth and throughput. Bandwidth is the highest amount of data that can be carried between 2 points in a given time period, usually 1 second. Common bandwidth units are bits per second, or BPS, megabits per second, or Mbps, or gigabits per second, GBps. Throughput, on the other hand, is the amount of bandwidth that is available for actual network communications. Network performance can be degraded by a number of factors, such as other required network traffic, packet loss, or latency. Therefore, network throughput can be significantly lower than its bandwidth. For example, the bandwidth of a home network might be 100 megabits per second using typical network cabling. Typical throughput, however, is usually only about 70 megabits per second. Therefore, this network loses about a third of its bandwidth due to what is referred to as communication overhead. Devices such as scanners, printers, computers, and mobile devices connect to a network using a wired and/or wireless connection. The network to which those devices are connected may or may not be connected to the Internet. An Internet connection requires the use of an ISP. On the other hand, an intranet is a private network and does not connect a device to the Internet. For example, the network at an organization or company is an example of an intranet. It is accessible only by the devices within the organization that owns the network. An intranet can connect various remotely located offices together without providing Internet access. Existing wired connection technologies are dial-up, broadband, and fiber optic connections. Dial-up connections use copper phone lines to connect to an ISP's modem. This speed, or bandwidth, is limited to 56 kilobits per second. This is the slowest way of connecting to the Internet. Broadband connections have higher quality copper phone lines, perhaps even coaxial cable, also known as coax cable. Broadband is faster than dial-up and runs in the approximate speed range of 768 kilobits per second or higher. Fiber optic communications transmit information by sending pulses of light through an optical fiber. Fiber optic speed range is around 500 megabits per second. Wireless networking technologies include Wi-Fi, satellite internet, and a number of technologies developed for mobile devices and mobile telecommunications, such as 3G, 4G, 5G, and LTE. Wi-Fi refers to technology that allows devices to connect wirelessly to a local network. Wi-Fi is typically used to connect laptops to a WAP, which in turn is connected to the wired network, usually through a switch or through some type of an ISP router. Wi-Fi is used frequently in hotels and airports. In fact, in most hotels, users are able to gain access to the Internet using some type of a Wi-Fi connection. Many small regional airports provide free Wi-Fi access to passengers waiting in terminals, whereas larger airports view this as a revenue opportunity, so charge for access. Wi-Fi speeds can range anywhere from 1 megabit per second, which is extremely slow, to well over 200 megabits per second. Wireless networking equipment functions in one or more wireless standards, such as 802.11a, 802.11b, 802.11g, or 802.11n. Each wireless standard specifies, among other things, the maximum theoretical bandwidth at which it operates. If the standard is 802.11g, for example, then bandwidth most likely is somewhere around 54 megabits per second, depending on the laptop's and/or the wireless device's proximity to the WAP. The farther away that a user is from a WAP, the lower the network speed or bandwidth will be. If the connection to a WAP is at 1 megabit per second, the user is probably too far away and needs to move closer. Another way of connecting to the Internet is using wireless telephone technology. 1G, 2G, 2.5G, 3G, 4G, and 5G are different generations of wireless telephone technology that were introduced consecutively as the technology developed. Most of the devices in 2016 operate on 3G or 4G. 5G is undergoing testing and is expected to be deployed soon. 3G is the third-generation technology that was introduced in 2001. It achieves data transmission speeds of up to 2 megabits per second and allows for high-speed web connection, video conferencing, and TV streaming. It adheres to the Wideband Code Division Multiple Access, or WCDMA standard. 4G is the fourth-generation technology. It was introduced in 2008. It achieves speeds of up to 100 megabits per second to 1 gigabit per second and consequently offers even more in terms of web communication, teleconferencing, and video streaming. There are two 4G standards in operation, WiMAX and LTE. 5G is the next major step in the evolution of mobile telecommunications. As of the beginning of 2016, it is undergoing testing and is expected to become widely available by the year 2020. This concludes Lecture A of Networks. In summary, this lecture defined what a communication network is and explained its purposes and benefits. It gave an introduction to the Internet and World Wide Web and described different ways of connecting to the Internet.